Welcome to the explainer for Cliff 12. Today we're focusing on why curing is a completely critical, active phase in Shotcrete quality control. If you've been following along, you'll already know that placing the Shotcrete is really just half the battle. What happens literally the minute the nozzle stops spraying? Well, that's what truly determines the long-term integrity of the structure.
Here is our roadmap for this explainer. Curing is not optional, rules and requirements, methods and inspection, weather extremes, field scenarios, and finally, the bottom line.
Section 1. Curing is not optional. The paradigm shift.
Here is the golden rule of Shotcrete you've got to remember. The nozzle might stop spraying, but your quality control absolutely does not. Curing is not some optional, nice-to-have finishing step. It is an active, essential part of actually producing the required concrete properties. Think about it. Fresh Shotcrete still desperately needs moisture. It needs temperature control, and it needs protection so that hydration and strength development can actually continue.
So why does all of this matter so much? Well, Portland cement hydration requires water to work. If the surface dries out too early, that hydration process right near the surface just stops dead in its tracks. And that early interruption reduces strength, increases shrinkage, and totally ruins the long-term durability of the concrete. Because Shotcrete surfaces are incredibly vulnerable, they're often exposed directly to wind, baking sun, and dry air right after placement, your moisture protection has to be planned out before the finishing even ends. You really can't just wait until the crew is packing up their trucks to figure out how you're going to cure it.
Section 2. Rules and requirements, the golden rule. Okay, let's talk about the strict limits you need to memorize, especially for the inspector exam. I want you to lock this exact number in your mind for your inspection checks right now. 70. This is a huge exam alert. Under the ACI 506.2 edition we use in this course, when the daily mean temperature is above 40 degrees Fahrenheit, curing has to be continuous for a minimum of 7 consecutive days or until 70% of the specified compressive or flexural strength is achieved. So it's 7 days or 70% strength, whichever period is less. And a quick note on this. When you're placing under colder temperatures, cold weather protection is still absolutely required until it hits that critical 70% mark.
Section 3. Methods and inspection. What to check.
Now, what's really fascinating here is how we take those curing methods and translate them into actual boots-on-the-ground field inspection checkpoints. We've got a few approved methods: continuous sprinkling, wet absorptive mats, impervious plastic sheets, and curing compounds. But for every single one of these, the inspector has to verify very specific field conditions. If they're sprinkling, you need to ask, is the water supply actually continuous, and is it hitting the wall without eroding the fresh surface? If they're using wet coverings like burlap, are they actually staying wet? Let's be real, a dry burlap sack is just a dirty blanket. It's not moist curing. For plastic sheets, are the edges fully secured so the wind doesn't just tunnel right underneath? And if they're using curing compounds, did they actually use the correct product at the required application rate?
Speaking of application rates, here's a very specific detail to watch out for. A gun-finished surface has a really rough texture, and that rough texture creates significantly more surface area than a standard, smooth, formed concrete wall. Because of all that extra microterrain, the applicable ACI requirement specifies a higher application rate for curing compounds on gun-finished surfaces, just to make sure you're getting complete coverage.
You also have to always ask yourself this one massive question: will there be another Shotcrete layer applied later? If the answer is yes, you've got a serious inspection concern on your hands. Applying a curing compound on an intermediate surface can severely interfere with the bond of tomorrow's Shotcrete layer. The curing method has to be perfectly compatible with the construction sequence. This right here proves exactly why an inspector needs to understand not just what's happening today, but the whole sequence of what happens next.
Section 4. Weather extremes. Hot and cold.
Mother Nature completely changes the curing game. Hot, dry winds, direct sun, and low humidity, they can rapidly suck the moisture right out of fresh Shotcrete. In those harsh conditions, curing might need to start promptly after finishing, using windbreaks, sunshades, or fogging. On the flip side, cold weather brings the huge danger of early freezing, which can permanently damage the cementitious material way before its strength even develops. That situation requires insulation blankets or heated enclosures.
But here is the catch. Cold weather protection is a full system. Heating alone fails if it ends up drying out the surface. Moisture retention alone fails if the water in the material freezes. And you really can't assume the protection is working just because you see some blankets tossed over the wall. The inspector has to verify the actual temperatures, paying really close attention to corners, edges, and thin sections, because those are going to cool down much faster than the center mass. And of course, you've got to keep reliable records of exactly where and when those temperatures were measured.
Section 5. Field scenarios. Good versus bad.
All right, let's put that QCI of yours to the test with some realistic field scenarios. Scenario 1. A wall is completed at 4 p.m. on a blazing hot, windy day. The crew decides to clean their equipment first and says they'll start curing in about 45 minutes. Guys, this is a seriously bad practice. Within 45 minutes, that surface is already drying out. Curing has to begin promptly when required, not after unrelated cleanup is done.
Let's look at scenario 2. You walk the site the very next morning and find wet burlap covering the wall. But when you reach out and touch it, the burlap is dry and warm. The curing system is entirely broken. Simply writing down burlap was installed in your notebook is a useless inspection failure if that material is bone dry and not providing continuous moisture anymore.
Scenario 3. It's freezing out, blankets are up, but there are absolutely zero temperature logs. As an inspector, just seeing insulation blankets with your own eyes doesn't prove the concrete is safe. Proper verification means actually documenting the real shotcrete temperatures beneath those blankets.
And these scenarios perfectly illustrate our 4-step inspector framework for literally every site walk. 1. What should I see? Continuous curing and proper protection. 2. What am I actually seeing? Maybe it's a dry surface, displaced blankets, or missing temp logs. 3. Why does it matter? Well, because it directly affects hydration, strength, and durability. And 4. What action is required? Restore the protection immediately and fully document the interruption.
Section 6. The bottom line. Key takeaways.
Let's bring it all home and wrap up this explainer with the absolute must-knows for your exam and your daily site walks. First, curing is never an afterthought. It begins immediately. Second, for the ACI exam, drill this into your memory for sure. 7 days or 70% of specified strength when it's above 40 degrees. And third, proper protection is always a two-part system. You're controlling both the moisture and the environmental exposure simultaneously.
If you take literally one concept to the job site tomorrow, let it be this powerful distinction. Placement creates the shotcrete, but curing develops it. Without the curing part, the placement is just compromised material waiting to fail.
We touched on extremes today, but what happens when the summer heat causes the mix to flash set right there in the hose? Or when a sudden freak frost hits mid-spray? The environment is never going to stop testing your concrete, which means your inspection can't stop either. Keep that inspector's eyes sharp, and I'll see you in clip 13, where we'll really tackle those hot and cold weather protocols.